And I have not shown an example like this. It's a perfect example. So I'll show it now before we go back to this. I did not get the chance to show an example like this. I would have done it, but I didn't get the chance last time. So the question here is y a function of x? So the question is giving us an equation, and we're asked, is y a function of x? So for now, I will say I have no clue. But of course, I will solve the equation first for y squared, moving x squared to the other side. And then what do I have to do to both sides to determine y? Thank you very much. So then y is plus or minus, because we know it's quadratic, so I have to obtain two solutions for y, the square root of negative x squared plus 2. So I solve for y. And now here's all I need to do is I'm going to say let x be 0. If x is 0, I get y equals plus or minus the square root of 2. So when x is 0, I get y to be the square root of 2 and also y to be negative the square root of 2. Now, knowing this, I will draw a conclusion. And what is the conclusion? Is y a function of x or not? No. Why? Because it's sufficient to show that for one x value, so to one x value, it corresponds to y values. Yes, ma'am.
So another question about that, because I remembered a different problem. It was already in y equals form, and then it had like 4 plus the square root of, let's just say 9x. And I got confused by that, whether or not.
So y equals what?
I think it was like 4 plus 9x or something. But it was the square root of 9x.
Like this?
Yeah.
Okay. So when x is 0, I get y equals 4. When x is 1, I get y equals 2 plus 4, 6. When x is 4, I get the square root of 36. 6 plus 4 is 10. And I can go on forever.
So why don't you get a plus and a minus answer?
I'm not solving. This is not y squared. I can't change that. It's y. It's carved in stone. I'm not solving for y. I didn't solve for y squared first and then took the square root. I didn't do anything. This was the function. I cannot do anything. It's already solved for y. I can only show that for each x value, I will get only one y value, and I'm done. It doesn't need any solving. It's already solved. So if it's already solved, I cannot add to it and say, oh, let me make it into plus or minus, or let me make it such and such. I can't. It's already solved. Does it make sense?
Yeah, I was just thinking if a number had the square root over it, then it
No.
automatically had a plus and a minus.
No. So be very careful. We talked about that. Let's review this because a lot of things we have to go over more than once. So x squared equals 4. When we take the square root or apply the square root, we get plus or minus 2. But if you remember, we said the square root of 4 is not plus or minus 2. The square root of 4 is only 2. Negative the square root of 4 is negative 2. So when you see a square root of 9, you can never write plus or minus 3. The plus or minus, remember, the intermediate step is this. And we solved these equations last time. That's why I get plus or minus. Because this equation has two solutions. Positive 2 and negative 2 have the absolute value 2. But not from the right-hand side. The square root is only a positive number. Always and forever. Here's the graph of the square root of x. That's it. You cannot have plus or minus. Because if you write it, the square root of x or the square root of 9, for example, is plus or minus 3. 9 is here, and you get only 1 point. This point is 9, 3. How do you get this point? when the function doesn't exist on that side. You can't. Perfect. Very good question. Very good discussion. I love this. Good. Anything else? Anything else? Okay, so let's go back then to the difference quotient. We were given a function. We came up with this function, 4x squared plus 5x plus 5x minus 2. And we were asked to determine the difference quotient. We proved what the difference quotient was, is the rate of change. It's almost the rate of change of a function at a particular point, almost. The difference quotient, you do not have to memorize it. It will be given to you in the problem. So it's f of x plus h minus f of x divided by h. And we analyzed the difference quotient and we said, oh yeah, of course, I know. This is nothing I can do to it. This is clear. So the only thing that I need to perform some operations on is this piece. And once I have it, I'm going to put everything together. So first, let's find f of x plus h. I know we found it last time, but maybe not everyone was in the clear, so let's do it again. So can anyone tell us how to start? What do I have to do in order to find f of x plus h? So I will have 4
times x plus h squared
in parentheses, x plus h squared, good, plus 5 times x plus h and minus 2. Perfect. Where is my starting point next, or my next step? I can never distribute when I see a power. Careful. I cannot touch anything here. If you, yes, I would say yes if you're saying, if you're talking about that. I completely agree with that. But here I cannot distribute. I have to square. Can anyone tell us a binomial squared has how many terms? 3 terms. Awesome. Thank you. You made my day. So can anyone now tell us which are those 3 terms? Very good. Plus 5x plus 5h minus 2. I hope that you do not have any doubts about this, because we discussed this on the first day of classes. Please. So this is 4x squared plus 8xh plus 4h squared plus 5x plus 5h and minus 2. All this work only determined this. Now I have 1, 2, 3 pieces to put together. I will have to subtract this, and which the negative symbol or negative sign in front of a function, or like this in 3 terms, will change all the signs of all terms that follow in here. And then h is h. Now, let's put it together. Do not do anything because I need to explain something. So I copy, instead of f of x plus h, I copy this whole thing. So 4x squared plus 8xh plus 4h squared plus 5x plus 5h and minus 2. I reach the negative symbol that needs to be distributed to these 3 terms. So I will write negative 4x squared minus 5x and plus 2. Negative 4x squared minus 5x and plus 2 divided by h. Do we understand this step? Is this okay so far? Everyone? Everyone? Any questions? Okay, so now the next step. 2 things have to happen every time we determine the difference quotient for any function. So please keep that in mind. I will write them down if you want me to, or you write them down, or both. So whenever we determine the difference quotient for any function, one more time, 2 things have to happen. What is the first thing? in this particular order, the first thing that has to happen is all terms from the numerator that do not have h. Any term from the numerator that does not have h must go away, must simplify. Otherwise, I know I have an error somewhere. Second step that has to happen eventually. This h from the denominator has to go away somehow. You can't erase it, but you can simplify it. So two things have to happen. One, all terms from the top that do not have h. Maybe it's always a bonus if some terms with h go away. That's fine. I don't care. Good. That's even better. But definitely all terms without h from the top have to go away. And eventually this h has to go away. The final answer will still have h in it, but not this one. Okay, so let's take a look at the top. Do you want me to write these down, these two? Yes? Okay, so number one, for any function, the difference quotient, always, all terms without h must simplify in the numerator. Step number two, in this particular order, little h from the denominator must simplify. Little h will still be left in the final answer, but not that one. Will still be left or exist in the final answer. So better, maybe I should have said, the final answer will not be free of h. So that's better. So whichever you want. Final answer will not be free of little h. That's more concise. Okay, so let's go back. I see a 4x squared with a negative 4x squared. Goodbye. I see a positive 5x with a negative 5x, and I see a negative 2 with a positive 2. So indeed, all terms without h went away. How many terms are left at the top? Yes, they all have to have h. So therefore, the next step, I'm going to continue here because I wrote a lot here in between. So they all have h in common, so h is pulled out. And that's how the h in the denominator will go away. But please tell me what is left in parentheses once you pull out h. 8x 4h, we took h outside, plus, that's it. As you see, the final answer is 8x plus 4h plus 5. It's not free of h. And this is it. I think we should choose another example and then move on to other topics.
So we don't have to put it in descending order when we...
X is the key. We don't care about age and the numbers. This is in descending order. X is the key. X is what I'm interested in, as X is the variable of the function. 4h plus 5 or not. Good. Would you like to choose another, or is this clear? Should we practice with one more? Yes? Okay. Would you like to choose, or I can choose? Okay, I will choose 84 on page 252. And the function is a negative 3x squared and then plus 2x minus 1. we're asked to find and simplify, bless you, find and simplify the difference quotient. Then the difference quotient is given to us as f of x plus h minus f of x divided by h. If you're doing anything else or any other homework, please stop. Bless you. Okay, and stop and please pay attention. I know some of you are way behind in the homework from chapter 1. Please, let's pay attention here. Okay. Which piece I have to work on? That's it. I have this, I have this, I have to work on f of x plus h. Good, f of x plus h. So please dictate, what would you write? We have to say parentheses. Very good. Yes. Yes. Excellent. This is indeed the first step. Good. What do I need to do next? Yes. So I have to copy -3, and then I square. Very good. Awesome. Plus 2x plus 2h minus 1. So now this is -3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 1. So finally I have that piece. Now I will put everything together to find and simplify the difference quotient. Can anyone dictate the difference quotient, and can anyone else tell us what has to happen whenever we calculate and simplify the difference quotient for any function?
Non-h terms have to...
Yes, all terms without h must go away from the top. Somehow they have to simplify, cancel out. And the second step,
H has to be in the answer.
h from the denominator of the difference quotient must simplify. Although, however, the final answer is not free of h. Good, so you're going to tell me to copy, instead of this, copy this, right? So -3x squared minus 6xh minus 3h squared plus 2x plus 2h and minus 1. Now remember, the negative sign in front of the function changes all signs that follow. Positive, negative, positive. So I have positive 3x squared minus 2x but plus 1 and h in the denominator. So what follows next? Yes, these two go away, these two go away, and these two go away. What is left? How many terms? 3. And they all have to have something in common that I have to pull it out. H indeed, because that's how the h in the denominator goes away, being simplified with an h from the top. Any questions? Okay, so then what is left in parentheses, please? Okay, one more time, careful. We are pulling out h.
Minus 3h.
Minus 3h plus 2. Is that clear? Okay, so then -6x minus 3h plus 2 is the final answer. And as you see, it's not free of h. There is another term in there that has h in it. Okay, So I'm looking at back at 2.1 to see if there is anything that I did not present to you, and I would like us to look at a word problem. On page 233. I'm looking at this graph because this is what this first section is all about, 2.1, looking at graphs and reading from the graph and so on and so forth. So these two problems, 103 and 104, refer to what we see here. It says we're given the graph. They also give us the function that represents this graph. And they're also telling us that this function, g of x, models the wage gap as a percent x years after 1980. So maybe I should start by reading the top. The wage gap is used to compare the status of women's earnings relative to men's. It's called the wage gap. The wage gap is expressed as a percent and is calculated by dividing the median or middlemost around earnings for women by the median annual earnings for men, the bar graph. So we have the information. They already calculated for us. And they came up with this function. We don't have to do anything. They worked hard. They came up with a function, and also they graphed the function for us. Finally, we have a question. Find and interpret the g of 10. Identify the information as a point on the graph of the function. And then, does g of 10 overestimate or underestimate the actual data? Because we are going to use the function as well. So first of all, let me just grab a pencil. So I don't have a pencil here. Yes. Okay, so this is the function g of x. It gives us the wage gap. And we're asked to find and interpret g of 10. G of 10. What does g of 10 mean? What is given in this question? Exactly. So I will draw, or imagine I draw a vertical line at 10. I see it crosses the graph at a point, and I will read the corresponding hard. I don't know if I'm right, but it's somewhere close to 70. That's in percent. So we should say, let's estimate. What would you like? This is 65 and this is 70.
68.
68. So 68%. I accept that. Now they're asking us to find g of 10, not from the graph, but using the function. What does that mean, and what do I have to do? Substitute x for 10 and perform the operations. And then we go back and compare and see if it's 68%, if it's lower, if it's 68%, or it's above. Very good. That's all I needed here. So let's take a look. So here's our function g of x. It's given as negative 0.01 x squared plus x and plus 60. And we want to determine g of 10. Negative 0.01 times 10 squared plus 10 plus 60. Here's what I recommend us to do. So let's do that. So one option, and I want to show this option, if we need it, it's not the case. We are only plugging in one value. We are only interested in one value. But I would like to plug in this function. Remember, when we start with negative, we put the operation, not the operational negative, but the negative sign. And we have 0.01 and times x squared. If you need time to, or if you have questions on this, please ask me, please, plus x and plus 60. So in y equals, I created this function, and I would like to plug in 10. Here's how I plug in always go to second, not always, I have to always go to a second and table set because the independent variable has to be in the ask mode, not the dependent. Do not change the dependent, which is the y value, just the independent, which is the x value. And now I go to second and table, and all I want is to plug in 10. And press enter. So I got the answer. So the function is giving us 69%. And from the graph, maybe it was 69. I don't know. Right? So the function is giving us 69%. From the graph, we read 68. Assuming that 68 is correct, is the function giving us an overestimate of the actual value or an underestimate of the actual value? Assuming that what we wrote is indeed correct. I can't guarantee. But let's say it was 68 from the graph. But the answer that we got from the function, it was 69 for x equals 10. I don't know, maybe for other x values, maybe even closer or better or worse. I don't know. But exactly for 10, the function gave us 69. The graph gave us, let's say, 68. So then, therefore, what would you say about the function for x equals 10 only? The function is overestimating the actual value of 68. What if this answer were 64? What would you have said? That the function is underestimating. Again, the assumption was that we read the correct value of 68. Okay, so before we look at more problems from section 2.2, I would like to present to you when a function is odd or even. I'll explain what that means. And I would like to explain when a function is increasing or decreasing or constant. So this is more information about functions, as well as max, min. Okay, so let's take a look at an example. So here's a graph. Is this a function?
Yes.
Yes, by the vertical line test. Good. I'm going to put some values in here. So I'm going to say 5 and 15. I'm going to say that this is -4 and this is +20. I just made those up. Okay, so now let's look at this function. We know it's a function. And what do you think the function does for any x value between -infinity and 5? Between -infinity and 5, the function does what? Increases. What does the function do between 5 and 15? Constant. Good. What does the function do between x equals 15 and forever to infinity? Decreases. Perfect. So then we write f increases on -infinity to 5. Notice that I don't care from which value to which value. I'm interested in the trend. The function is increasing for x values between -infinity and 5. The function is constant on the interval 5, 15, only parentheses, not brackets. It's about the trend. And f is decreasing on the interval when x is 15 and above. 15 and infinity. We don't care from which value to which value. Good. So that's the idea of increasing, decreasing, or constant. Functions don't have to be increasing, decreasing, and constant. Maybe always increasing, or maybe only decreasing. Okay? So I chose one so we can discuss all options. So here's another graph for you. So here's the graph. We're going to graph these functions in chapter 3. So this is a function f of x. And I'm going to name this point, and let's say is 5, 8. I'm going to name this point, let's say is 10, 2. Sorry, it should be horizontal, my hand. Sorry about that. Okay, perfect. So what can you say about the function between negative infinity and 5? What does it do? Very good. What does it do between x equals 5 and x equals 10? Okay, and obviously then increasing. This point, because I can show an interval left and right where all these values are smaller than it, will be a local, what do you think? Local max. This point, because I can show an open interval where all these values are higher than it, what do you think? It will be a local minimum. Yes, please.
I have some confusion because one of the videos from the book, the guy was like, technically, this local max and local min could be considered a constant. So then I'm going to do the homework, and I'm like, okay, is it a constant? So I put it in. The book never likes that as an answer. So is that something we'll come across later, or is that just not true that those points could be considered constants?
What you're referring to is basically something like this.
But the graph that they showed in the video.
I don't think that you're referring to a graph like this.
That was the graph that he used in the book. That's why I was confused. He was saying technically it could be considered constant. It didn't make sense.
Does it depend on the scale of the graph?
Can you bring that up? Because if it was confusing for one student, it's enough for me. So can you bring this up?
Yeah.
Can anyone bring it up? I need to see it.
I have my laptop.
That's okay. Come up here. Let me. Can I log myself out while I'm taping? Yes, I can log myself out. Yeah. So let me log myself out. This is very important. No. I'm not putting password or anything. You just got
Yeah,
it.
no.
So just log yourself in into Canvas, and if you want to go to, if you remember what it was, I think the function was probably had a piece that was constant. If you find it, let me know. Because I really need it here, but as long as you tell Ben where to look for it. There are two schools of thought, and I'm very happy because I have the calculus book right here. And I will show you. I don't want to make a big fuss out of this because this is not a major topic, but are we there yet? You found it?
You did? Okay, I haven't found it yet.
Is it this one? He says it could be a constant.
Yeah.
I think it's this one.
And
It
it's
says in
on.
previous description, the graph is indeed a constant.
Yeah, that's like this similar graph to one she had, right? With uneven.
Oh yeah, that's why we don't use we use only parentheses. Yeah, he's talking about something else. I got it, Ben.
Okay.
Okay, so let me explain what he's talking about. He only says this: when you use intervals for the trend, you cannot include the endpoints of the interval. Because at any particular point, the function is constant. So I'm telling you the function is 2, 3 at this point, right? So at this point, the function is constant. At this point, it's not increasing or decreasing. At this point, the function, when x is 5, y is 8. Done. It's not 8 doesn't go up or down. So between negative infinity and 5, the function is increasing. That's why we write f increasing on the interval negative infinity and 5. We do not write this, although this algebra book does it sometimes, but that's wrong. So that's why we used an open parenthesis, because at 5, f of 5 is 8, which is not increasing or decreasing. It's constant. It's just one number. Here, the same thing. At this point, it's not decreasing or increasing. It's just one number. At x equals 10, y equals 2. But it's increasing when x is between negative infinity and 5, union from 10 to infinity. And it's decreasing from 5 to 10. So this is union, 10 to infinity, and f is decreasing on the interval 5, 10. That's why you see I'm only using parentheses, not to include any particular point where the function will be just a constant. So when you say my income increased between the year 2000 and the year 2005, then you're not restricting at any particular point. So you're using parentheses because that's your trend. Your salary increased. But at any particular day, it was a fixed number. It didn't increase or decrease. Yes, please. Right? So is that better?
So for our purposes, though, we're not worrying about that. Like, that's more of a technicality that we're not getting into?
No, at any particular point, the function is a constant. We're talking about the trend between, I got it, I saw that, 1 second. So between this x value and this x value, the function is increasing. At this particular point is constant. At this particular point, let's say 3, 3 is constant as well. 3 doesn't change. It does not go up or down. But the function goes up between negative infinity and 5. That's the trend. Yes, please.
Why do you put the union in between?
Because it's increasing on this side and increasing on that side. Two pieces of increase. You were writing them together, yes. Yes, very good question. Is this okay? Better? Very good point. Very good point. I just need to log myself back in. Good. Perfect. Where are we? Okay, so we know what the local max, local min represents. We know the intervals. We call them intervals of monotony. Well, you don't have to remember that. So when it's increasing and decreasing or constant. So these are the max min. So now we're ready to figure out everything, a lot of questions about any graph that you would like to pick. And then we talk about symmetry. Maybe I should talk about symmetry first. Let's talk about symmetry, and then we look at, I was trying to find something to show you in the calculus book, but I can't find it, and I don't want to waste your time. Your book uses equal symbols on the increasing, decreasing. The calculus book does not. But it's not important. I'll find it and show it to you next time. Okay, so I think I'm on page 6. Yes, I am on page 6. Okay, so functions can be symmetric. It's nice when they are. They don't have to be. So let's talk about even and odd. Has nothing to do with even numbers or odd numbers. Nothing. It's just the name of a function. Even functions have a property, and I will write the property in a minute. Odd functions have a different property, and I will write the property in a minute. So this is for functions. So let's start with an example. Let's look at this graph. So maybe I should just call it symmetric functions. Okay, so here's what I'm going to do next. So please watch for a second. I'm going to draw a horizontal line. I'm going to create 2 points. I'm going to name this point x. This is our function f of x. And can you please tell me the y value of this point? I don't want you to look on the other side. I just want you to tell me how much is this height. Say it again. Well, no numbers, please. Yes, y, but I want the other one. You're right. There is another one that represents y. Of, that's it. So this value here is f of x. If this is x, this must be f of x. If this is 5, then this is f of 5. If this is 3, this is? Excellent, perfect. Now forget about the right-hand side. For a moment, don't look there. And I will say that this, obviously, from my graph, will be negative x. Don't look on the right-hand side. And please give me the value here. Excellent. Good. Now I would like you to come up with a relationship between f of negative x and f of x. What do you think? They must be equal. This is what we call an even function, which will be symmetric with respect to the y-axis. Symmetric with respect to, this is how lazy people write, with respect to the y-axis. So functions can be even, which means their graph is symmetric with respect to the y-axis. The algebraic relationship is this. Here's an example. Do you think that f of x, which is x to the 4th minus 2x squared, is this an even function? And you should say, I have no clue. And if that's the case, we have to determine f of negative x. We know how to determine f of negative x. We will plug it in. How much is negative x to the 4th power? Negative x to the 4th power equals x to the 4th power. Negative x squared equals positive x squared times negative 2. So now the question is, if this equals the original function, then we will say yes. When we get the chance to graph this function, we will graph it symmetric with respect to the y-axis. If they are not equal, then we will not graph it as a symmetric function, and we need more work, we need to find more points, who knows. So f of negative x is this piece, f of x is this piece. If they are the same, I'll say yes. If they're not the same, I'll say no. Are these two quantities identical? Yes. So I will say yes. The function is an even function, symmetric with respect to the y-axis. Any questions? Okay. Here's the other possibility. This is another graph that we will discuss. You may have seen it before. Notice that I did not graph it like this. It's a totally different story. I graphed it slowly. Here's what I'm going to do now. I'm going to connect 2 points with a line segment on the graph opposite, with a line segment going through the origin. I'm going to, of course, say that this is x, and you will tell me what this is. Excellent. Forget about that side. Please do not even look. I'm going to say that this is negative x because it's exactly opposite. And can you please give us, anyone give us this value? Excellent, f of negative x. And this time I would like you the same thing to tell me the relationship between f of negative x and f of x. And you can no longer say equal because one is positive and the other one is negative. So this time you cannot say that they are equal, but you will say that they are, what word am I looking for?
Be the inverse.
Opposite, not the inverse, because inverse means 2, 1 over 2. But the opposite means 5 and negative 5. So this is indeed the opposite. And this means that the function is symmetric, again, with respect to the origin. A function that is symmetric with respect to the origin is called odd. It's an odd function. It has nothing to do with odd numbers. It's just a name. It has the property of being odd, meaning it's symmetric with respect to the origin. So here's an example for you. Let's say f of x equals 2x cubed minus 4x. A function cannot be odd and even at the same time, although there is one, but nobody really cares about it. It's y equals 0. So the x-axis is symmetric with respect to the origin, and also symmetric with respect to the y-axis, but no one cares about y equals 0. Okay, so what do I need to determine? Exactly what I determined a minute ago. I have to find f of negative x. That's the key. In both relationships, as you see, f of negative x is the key. So then I have 2 and negative x to the third and minus 4 times negative x. How much is negative x to the third power? To the third power, yes. Negative x to the third power is negative x cubed. Very good. How much is negative 4 times negative x? Good. So now I'm asking myself, does this equal the opposite of f of x? I don't know. I haven't calculated the opposite of f of x. I have not calculated it. So I multiply both sides by negative 1. So negative f of x, as we had in the difference quotient, will be negative 2x cubed and plus 4x. So now the question is this the same thing with this? If they are the same, then I'll say the function is odd, which means when I get the chance to graph it, it will be symmetric with this, its graph will be symmetric with respect to the origin. Any questions on odd and even? So let me show you a couple of graphs. What about this graph? Is this graph symmetric with respect to the y-axis? So it's an even function. Is this graph symmetric? It's symmetric with respect to the origin, so it's an odd function. What about this graph? Symmetric with respect to the origin, so it's odd. What about this graph up here? It's none of the above. It's not symmetric with respect to the origin. It's not symmetric with respect to the origin, and it's not symmetric with respect to the y-axis. Very good. Okay, so here's what I would like us to do next, because now we have all this information. We're going to look at this graph or choose any other graph. If this is not suitable, we can choose. So this is one option. You choose. This is the second option. You choose. This is the third option. You choose. Please choose. Or this is the fourth. These are the only 4 problems we have here. The second one up here, this one? Okay, perfect. So we're looking at problem 50. Please write it down. 50 on page 251. And let's answer all their questions. Because I can't go back and forth, so please write it down and then I can write it down from you. I don't want to interrupt and zoom out and zoom in and zoom out and zoom in. Or I can just write it on the side paper. I can do that. Okay. So first question on this graph is, I'm adding some questions in here. Is this a function? By the vertical line test, this is a function. Perfect. Number 2. Please find the domain of this function. Yes, would you agree is negative infinity to infinity?
Yeah.
Everyone? Negative infinity to infinity. Please write it down. Domain, negative infinity to infinity. Next question is about the range. Can anyone identify the range? So you said the domain, negative infinity to infinity. And range one more time. Negative infinity to 4 with the bracket, please. Negative infinity to 4. X-intercepts. Can anyone dictate? Negative 4, 0. And 4, 0. Any questions on that?